Hi there. This is the first in a series of videos where I want to be measuring stuff all around us that make noise. We are exposed to voluntary or involuntary noise every single day. So it'd be cool to see how loud things actually get. So for today's experiment, I have a circular saw. We're going to go outside and cut some wood. I'm going to try and cut wood at a longish period of time to try and get some cool SPL values. I also want to measure the frequency response of the circular saw. So one of the things I was thinking about when I wanted to create this video and the videos to come is how can I accurately represent what I'm hearing? And well, I hear with my ears, so I need to get the microphone as close to my ears as possible. So I've got my hearing protection and I put a clamp on it with some sponge in where I can take my measurement microphone and clamp it in there. So when I put it on, it's close to my ear. So as I'm working the circular saw, it would represent what I would be hearing if I weren't wearing these. So in Smaart, when we want to measure SPL, this microphone needs calibration. This is a iSEMcon SC1 calibrator. It has 94 dB setting and 110 dB setting to calibrate for SPL. So when you switch it on, see if my mic picks this up, plays a 1 kilohertz tone, and it has a little insert that's the right size for the microphone. Put the microphone in there and you switch it on, and we can calibrate the microphone. So where do we do this in Smaart? Well, first we have to go to the I/O config and make sure that the preamp our microphone is plugged into is selected. So I can go give it a friendly name. The input, I'm plugged into the first input of the Smaart I/O. And at the moment you can see that there's no calibration offset. At the bottom here, there's the calibrate button. We need to switch phantom power on. Oh, that's the right input. We don't want the right input, we want the left input. So just double check your input device and input channels. And if you're happy with the input level, it needs to be relative to how loud you think this is going to get. So if you adjust the gain or lower the gain, just consider some headroom for how loud you think your content is going to be. Then we just hit calibrate. So once it's reached 100%, it's measured the calibration offset value. And if your calibrator is set to 110 or 114, like some calibrators, this is where you can adjust that and select calibrate. Great, now we are calibrated for SPL. So in the configurator window, there's also the SPL config. Here I can set up different meters for the same input, but to give me different SPL values. So I can go and set this to SPL slow, SPL fast. This is the LEQ setting. So LEQ takes an average over time. So LEQ1 means average over 1 minute. There's also a LEQ5. This is one that I custom created under the advanced meter configuration window. And here I can adjust the time of that LEQ that I want to measure. And there's also exposure, OSHA and NIOSH exposure levels. So here I can say show meters, and here are my SPL meters. I can adjust the alarms for the inputs. So I can say all calibrated inputs and say what SPL measurement it needs to set off the level or the alarm. And here I can set the threshold to say if it goes above 110, the meter will start flashing red and an alarm will come on. Okay, meter color config. Here I can change the colors. You can see that the exposure level is in green. but the RTA 420 dB LEQ5 is in yellow, and these are the thresholds that I can set. So everything above 105 dB will turn red. Everything above 94 dB will turn yellow. Everything above 85 will be green. I can select it per meter or per SPL value, and I can apply it to all if I want to assign these thresholds to all of them. Okay. On the right hand side here is the logging file settings. It logs it in a text file, and I can go select where I want this to be saved. I can tell it at which interval of seconds does it need to take or record the data. SPL history opens up the SPL history window, and this will be the live history over time of the SPL. And log config, I can type in here some information regarding this log file. So I'm going to be in my back garden, and we're going to select that input. Perfect. And when we are ready, we just click start logging. I'm not ready yet. I want to set up some RTA responses, some spectrum, so I can see the frequency response. I can go to my measurement configuration and create a new spectrum. So this one we will call RTA infinite, and we're going to select the Smaart I-O and the RTA 420. And the next one we're going to call RTA 10 seconds. Okay. So I want to set this up separately so that they have different averaging options. So if I double click on the input or the measurement engine, it opens up the measurement configuration window. And at the top here at averaging, I can untick use global and say, I want just this meter or this RTA to show me an infinite averaging. Okay. And at the 10-second one, I'm going to do the same and select 10 seconds. Cool. Perfect. So you can see my 1 kilohertz sine wave is still playing. So one last thing I want to do is in my spectrum options, I want my RTA response, the y-axis information, the amplitude information to match the SPL that I've just calibrated. And that you do here where it says plot calibrated level. You apply. There we go. So you can see how the traces are moving very slowly because the one is an infinite response and the other one is a 10-second response. Awesome. So let's head outside and go and cut some wood. Cool. So that was fun. I ended up wasting about 5 minutes of my life. The first piece of wood that I cut, the microphone lost connection. I clamped the microphone on the locking clip of the female XLR, and it pulled out as I pulled on it. So I've wasted 5 minutes of cutting wood and not actually collecting any SPL information. But then I went back, recalibrated, I set up the inputs again, made sure everything was fine, started the video, recorded the word, got all the information, but unfortunately, as you saw, I did not have the SPL meters visible for you guys, and I also did not have the history window um, visible. There we go. SPL history window visible. Um, so I am sorry about that, but we'll review that history just now. Let me just grab it over here. There's my unplugged data. Let me show you that. So everything is like super low. It managed to just stay intact enough to get some audio through, but it wasn't enough. So I had to go again, and I had to go and measure it all again. So if the SPL window was open, you would see at the top here is one measurement at a time, where you can view it. And at the time, as it measures, the time passes at the bottom here and it collects the information. At the bottom, you can overlay all the various SPL settings. You can see like the longer LEQs didn't actually record any good information because the meter was running, but the cutting time was only, I mean, what's that? 10:59, 10:56. So about 3 minutes worth of high SPL information. So the meters didn't stop running when it was unplugged, and then it just carried on. So the LEQ5 and the LEQ10 settings won't actually give me any good information. But here we can see all the different values. You can cycle through the values by using the Z key, the Z hotkey Z. Okay, so SPL peak, sitting around 115 up to about 120 at some instances, 221. dB SPL-A fast. So if I just use this one point of reference, 107, and go to SPL fast, 107.8, and this is LEQ1, 101, 103. So this is a great way to see all of the different SPL values staggered on top of each other. Just looking at the frequency response, this is quite interesting. So very little low frequency exposure below 250 hertz. So the actual circular saw isn't reproducing frequencies below there. Funny little peak here at about 450 hertz. And then I'd say the good chunk of the noise that the SPL or that the circular saw makes is from about 620 all the way up to about 15 kilohertz, with 4.5 up to 15 being quite loud. And those are a lot of the frequencies that we end up losing over time. So that's quite interesting. Some of this information could be from the wind. It was a little bit windy outside, so it would be difficult to see unless someone was looking at, I mean, we could probably look at the screen if we had a fast averaging going to be able to see the effect that the wind was making on the measurement. But yeah, there we go. Awesome. That was a circular saw. Please let me know if you have any questions or if you have any comments or suggestions how I could do this better, more information that you want to see, and we'll see you for the next one. Thank you.